Now, in this video, we'll be looking at how to draw the Lewis structure of the nitric acid. But to do that, first we will need to determine the total number of valential electrons in this compound. Now, hydrogen is the first element on the periodic table in group 1 and in the period 1. So it has 1 valential electron. Now, nitrogen is in group 15 on the periodic table, having 5 valential electrons, and oxygen is in the group 16 on the periodic table, having 6 valential electrons. It is also important to take note that nitrogen and oxygen are both in the second period on the periodic table. So the maximum number of electrons that nitrogen and oxygen would have in their second shell is 8 electrons. So nitric acid has 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atoms. Now, hydrogen has 1 valential electron, nitrogen has 5 valential electrons, and oxygen has 6 valential electrons. And so we're going to have a total of 24 valential electrons that we are going to work with in determining or drawing the Lewis structure of the nitric acid. We need to determine which of the 3 atoms best is suitable to be considered as the central atom in drawing our Lewis structure. And we will be guided by the factors. 1, that which atom makes more bonds. 2, the electronegativity value of the element. Now, hydrogen is in group 1 on the first period with 1 valence shell, and it would require 1 electron extra to get to 2 in forming a covalent bond and achieving the duet. Nitrogen is in group 15 on the periodic table on the second period and having 5 valence shell electrons, and it would need 3 more electrons to get to 8 to achieve the octet. And so nitrogen can make 3 covalent bonds. Oxygen has 6 valence shell electrons and would need 2 extra electrons to get to 8. So of the 3 elements, nitrogen is able to make more bonds. And the more bonds that it makes, the more suitable it is to be considered as the central atom in drawing our Lewis structure. Now, if we are to consider the second point, which is the electronegativity values, hydrogen has an EN value of about 2.20. Nitrogen, about 3.04, and oxygen has electronegativity value of about 3.44. Now, in terms of these electronegativity values, hydrogen has the least of the 3, but hydrogen can make only 1 covalent bond and the least of the number of bonds that the 3 atoms can make. So of the 3, we will go in for the atom that makes more bonds, which is nitrogen. So nitrogen will be considered as our central atom in drawing our Lewis structure for the nitric acid. So let's have the 3 oxygen atoms and 1 hydrogen atom around it in our skeleton structure. Now let's link up the atoms with each line consisting of 2 electrons. So we have 8 electrons here, linking up the atoms together. Now we're working with 24 electrons, so we need 16 extra electrons to distribute. So here we have 24 electrons distributed. Now, with this structure, you would realize that this oxygen has 8 electrons in its valence shell. It has achieved the octet rule and it is satisfied. So is this oxygen atom. Now, nitrogen has 8 electrons in its valence shell electron and it has also achieved the octet rule and satisfied. Hydrogen has 2 electrons in its valence shell, has achieved the duet, and is also satisfied. This oxygen has 6 electrons in its valence shell, 2 involved in bonding, with 2 lone pair electrons not involved in bonding, making 6 electrons in its valence shell, and this particular electron atom is not satisfied. And so it will make this particular Lewis structure for nitric acid unstable and not the most favorable one to consider. And so now we will need to consider a skeleton structure with a different combination that would ensure that all the atoms involved in this bond are satisfied. Now, so let's link up the atoms in a different combination with a different skeletal structure. Now, the atoms are linked together with lines with each line representing 2 electrons, making 8 electrons here. So we would need to distribute 16 more electrons to make up for the 24 electrons that we are working with. So we're going to go ahead and distribute 16 extra electrons. So we have our 24 electrons all distributed. Now, hydrogen has 2 electrons in its valence shell. It is satisfied because it has the duet arrangement in its valence shell. This oxygen is satisfied, having 8 electrons in its valence shell. This oxygen is also satisfied. This oxygen is satisfied. But nitrogen has 6 electrons over here. Nitrogen in this Lewis structure is not satisfied. So in order to ensure that nitrogen also achieves the octet, we can either convert this lone pair into a bond, or this into a bond, or this lone pair into a bond. So in either case, when we so do, we could have the following Lewis structure arrangement. Now, if we are to have this lone pair converted into a bond, we could have this Lewis structure. And with this Lewis structure, hydrogen has 2 electrons in its valence shell. It has satisfied the duet. It is satisfied. This oxygen has 8 electrons in its valence shell. It has satisfied the octet. This oxygen has 8 electrons. It is satisfied, having achieved the octet. So is this oxygen. And now oxygen has 8 electrons in its valence shell, and it is satisfied. And so are each atoms of this Lewis structure also satisfied, having achieved either the duet with regard to hydrogen or the octet with regard to oxygen and nitrogen. And it so applies to this Lewis structure. But there is another step that we would have to consider, which is to determine the formal charges on each of the atoms within the compound. And with that, the fewer the separation of charges, the more stable the Lewis structure is, and the more favorable that structure would be considered as the Lewis structure. Now, to determine the formal charges on each atom, we will be guided by the formula So here we have the valence shell electrons minus the non-bonding electrons minus half the bonding electrons. So for this Lewis structure, let's determine the formal charge on each of the atoms. Now, hydrogen has valence shell electrons of 1. And in this arrangement, hydrogen does not have a non-bonding electrons. It has only one valence shell electron and it is involved in the bonding. So the non-bonding electrons for hydrogen is 0. And the number of bonding electrons is 2. So we're going to have half of 2. So hydrogen has a formal charge of 0. This oxygen, valence shell electrons of oxygen is 6. The non-bonding electrons are 4. And the bonding electrons, we have 2 here and also 2 here. So this oxygen has a formal charge of 0. So going by the same formula, we can determine the formal charges on each of the atoms in the structure as indicated. With this oxygen atom, valence shell electron of 6, the non-bonding electrons is 4, and the bonding electrons is 4. So this oxygen atom would also have a formal charge on it as 0. This oxygen will have non-bonding electrons of 6, and bonding electrons of 2. And so we're going to have the formal charge on this oxygen atom as -1. Now, for nitrogen, nitrogen has valence shell electrons of 5, minus the non-bonding electrons, which is 0, because all its valence shell electrons are involved in the bonding, minus half its bonding electrons. Now here, nitrogen has 8 bonding electrons. We have 4 here, 2 here, and 2 in this bond. So nitrogen has 8 bonding electrons, which means that the formal charge on nitrogen is +1. So that means that the algebraic sum of the formal charges for this Lewis structure is 0. Now, if we are to apply this same formula on this structure, on this Lewis structure, we're going to get for the formal charges on each atom as indicated. And here to the algebraic sum of the formal charges within this Lewis structure is also 0. And when we are to apply the same formula for this Lewis structure, we're going to have and again for this Lewis structure, the algebraic sum of the formal charges on this Lewis structure is also 0. But this particular Lewis structure has more charge separations compared to the previous 2 Lewis structures. We have +1, +1, -1, and -1 here. And the more the charge separations of the Lewis structure, the less stable the Lewis structure. The fewer the charge separations, the more stable the Lewis structure. So this first Lewis structure and the second Lewis structure will be considered more important and more favorable Lewis structure to be considered for the nitric acid than this Lewis structure having 4 charge separations. So the actual Lewis structure for the nitric acid is going to be between this Lewis structure here and this one. So these 2 structures over here will be considered as resonance structures of nitric acid, which means that the actual Lewis structure for the nitric acid is going to be a hybrid of these 2 resonance structures. So we're going to have something of the form in which case we're going to have one single nitrogen-oxygen bond and 2 nitrogen-oxygen single and half bonds. In which case, because of the delocalization of the electrons, this oxygen atom could assume a negative formal charge, or we could have a negative formal charge on this oxygen atom, representing the hybrid structure for the nitric acid. So this is the end of my video. Thank you very much for watching, but keep watching.